Hello everyone, and thank you for deciding to join me again. Last week we looked into the ways in which forensic teams search for evidence, and this week we will be looking into how forensic teams recover fingerprints. Okay then, so what sort of things are we going to be looking at today? Well, we're going to have a sort of general introduction to the topic at hand, and then we're going to move on to the slightly more specific stuff, looking at how to recover fingerprints from non-porous and porous surfaces, the special kinds of lighting and photography that are used, and then we'll talk a little bit, and by a little bit I do mean a very, very small amount, on elimination and matching, because we'll discover all about fingerprint matching sort of later on in the series, and then we will end with looking at some special treatments that are used. So very few things then define our identities as precisely as a fingerprint. But the power of fingerprints as evidence lies not just in their uniqueness, but also in their simplicity and familiarity. Collecting and analysing them at a crime scene does not require costly, complex technology, and juries understand and trust them without explanations from an expert witness. The swirling patterns of our fingerprints are unique. Even identical twins with identical DNA can be distinguished from one another by looking at the ridges on their fingers. It is these ridges and the secretions from the sweat glands that line them that leave telltale traces on everything we touch. At a crime scene, finger marks on shiny surfaces may be obvious, but many more may be too indistinct to be seen with the naked eye. Using a variety of treatments such as powders, chemicals, and lighting techniques, these latent fingerprints can be revealed and enhanced. Although fingerprints are the most common marks found at crime scenes, palm prints, bare footprints, and even ear prints can also be recovered using the same methods. However, these additional prints are of limited use, as police only have databases for fingerprints. The best known technique, and still the most widely used, is dusting. Examiners use soft brushes to apply a powder, such as finely ground aluminium, to non-porous surfaces that a suspect might have touched. The powder sticks to the moist, greasy lines left by the sweaty skin ridges. Light, dark, and coloured powders can be used to make the prints stand out on different coloured backgrounds. Once powdered, the mark can be lifted from the surface using low-tack adhesive tape and mounted onto an acetate sheet to be preserved as evidence. If marks are on a porous surface, such as paper or cardboard, the sweat residue is absorbed by the material. Dusting with most powders does not work, although metallic powders can achieve some sort of result. For most porous surfaces, examiners tend to use chemical reagents such as nihydrin and DFO 1,8-diafluorine-91 that react with chemicals present in sweat. Porous objects are dipped in or sprayed with the solutions and then warmed in an oven. Nihydrin-treated prints turn purple, as seen in the photograph, and DFO makes fingerprints glow when they are hit by laser or blue-green light. There are several other widely used chemical treatments. Physical developer, PD, a solution of silver and iron compounds, can reveal prints on porous surfaces that have been soaked in water. Fuming with iodine vapor gives prints a brown color that fades rapidly, so prompt photography is needed to record the image. Iodine fuming also enhances prints on non-porous surfaces too. Some enhancement techniques are potentially destructive, and some will not work if preceded by another. Examiners at the crime scene and laboratory technicians use their knowledge and experience in deciding which method to use. As a precaution, they photograph the developed marks at each stage of the process before applying further treatments which could obliterate them. Anyone who opens a window to clean it or turns a glass to catch the light will know that doing this can make formerly invisible fingerprints stand out clearly. This is the most basic lighting technique used by forensic photographers to record fingerprint evidence. They train a powerful white light on the mark and then move the camera or the light until the print appears. Faint prints on very shiny surfaces sometimes stand out with coaxial illumination. This uses a diagonal semi-transparent mirror in front of the camera lens to reflect a shaft of light at the print, which appears as a dark pattern against a white background. Most of the other photographic techniques are enhancing fingerprints using special illumination rather than white light. Shining brilliantly colored light at a print often makes it stand out, especially if it has been treated with nihydrin or DFO. Ultraviolet radiation is used in combination with fluorescent dusting powders, and after superglue fuming, argon ion blue-green laser light can exceptionally reveal fingerprints that do not respond to other treatments. The FBI used this technique in 1984 to reveal prints left on a postcard sent by the war criminal Valerian Treffer to the head of the Nazi SS 42 years earlier. Examination of crime scenes does not just produce the perpetrator's marks. Prints of innocent people, such as the owners of a burgled home, are obviously far more numerous. To eliminate these people from the investigation, their fingerprints are recorded by inking and pressing on card. The process of matching pairs with those of suspects and known criminals will be explained later on in the series. In the laboratory, technicians can develop fingerprints with methods that are tricky to use at a crime scene or that require toxic reagents. The most commonly used techniques is superglue fuming. In moist conditions, the vapor from superglue bonds with the sweat residue of latent prints and marks them visible, even on difficult surfaces such as flexible plastic. Developed marks can then be dyed and powdered. Powders and special lighting can improve contrast. Vacuum metal deposition, or VMD, is the most sensitive of all lab techniques. Objects bearing latent prints are enclosed in a pressure vessel. The air is pumped out and the chamber filled with metal vapor, first gold and then zinc. The metals condense on ridge patterns, making prints visible, though further treatment with superglue is sometimes necessary. VMD is time-consuming and expensive and can reveal old prints and those exposed in water. Okay, and that is the end of this video. I hope you enjoyed it. Be sure to check me out next time, where we will be looking at how to recover shoe prints and tire tracks. Also feel free to comment on what you think of my videos and let me know your thoughts and ideas for any future series that I could do. Catch you next time. Bye!